Friends, thank you for joining me again in the old computer shack. I apologize again for my dirty fingers. This is the same night as the previous video, and I've been working on the hay barn all afternoon and the grease won't come off, so you'll just have to deal with my filth. Anyway, so this is the hard drive out of this machine. It is a Connor CFS 420A, that being 420 megabytes, actually a little bit less than that. And I decided that I would just take a disk image of this thing just to preserve whatever data was on the machine, even though it'll go onto my network RAID and I will never look at it ever again. But it makes me feel better to, archive this stuff. So my usual procedure for that is to use my handy dandy crappy old slow USB 1 parallel ATA 3.5 or 2.5 or SATA to USB dongle. USB 1. It takes forever, but I guess it gets the job done. So I plugged this thing in here as usual and took it down to the Linux box and fired it up. And lo and behold, it wouldn't read the stupid disk. I don't know what was going on. I tried a bunch of different things and I couldn't get it to read. I couldn't get it to mount the drive. I decided that I would find a where did I put it? Find a IDE cable. This is the one that came out of the machine. See, it's only got one connector on it. I would find an IDE cable with two connectors on it and plug in an IDE zip drive. This is not an Atapi zip drive. This is an actual old school IDE zip drive, and then I would slap one of my handy dandy zip disks in there or two, and there was a little more than 100 megs worth of stuff on here, and back up the wonderful disk drive onto the wonderful disk zip disk, and everything would be happy and grand. But little did I know that my IDE zip drive doesn't work. It won't even eject disks. I don't know what's wrong with it. These things, they break all the time. I really like having the auditory feedback of an actual disk drive running, but some days I think maybe I should switch all of my old boxing to CF. So after I discovered that, I hunted up a which one is it? That's the wrong one. I hunted up an 8-bit SCSI card, future domain. What is this? An 850 with an external DB25 port, and I put it in the machine, and into it I plugged a external SCSI zip drive, and the card didn't even see the zip drive, and I was like, what the heck? So I thought maybe I needed to remove these termination resistor packs, but those things are a pain in the butt to get in and out of there without totally demolishing the pins. So instead I got rid of this thing and plugged in a internal SCSI zip drive, and I know this one works. The controller saw it, but F-Disk couldn't do anything with it. I assume that the SCSI zip drives, unlike the IDE zip drive, the SCSI zip drives must act as like SCSI removable storage and require a driver in DOS in order to work. That's my only supposition. But it saw the drive wouldn't work. I thought, dagnabbit, well, I'll just try yet another SCSI card, this Seagate 8-bit SCSI card, and I had the same result. So that was aggravating. The next order of business, after all of that fail, let me put my stuff away here. The next order of business after all of that fail, was to whip out the XTCF card out of my Tandy 1000. I do not like to take that machine apart, but I did, and I put it in there, and the option ROM came up happily, and it booted, but it would not work with the internal IDE controller. So from there I went to an actual complete XT IDE card that can support 16-bit ATA devices, and put it in the machine and plugged the disk into it, and it booted. So I tried the IDE zip drive again, just in case, and it didn't work. So at that point I scrounged up this 40 gigabyte Western Digital parallel ATA drive and plugged it in as a slave, and it booted and saw them both. Now the XT IDE BIOS can work with LBA drives, unlike the BIOS that's on this board. However, DOS 6.22, which is what is on this machine, can't create partitions larger than what, like 2 gigabytes or something like that. FDisk treats the entire disk as 8 gigabytes, and it can't create partitions larger than 2 gigabytes. I think that's how that works. FreeDOS can actually work with FAT32 partitions, so that's what will eventually go on this machine, because I'm going to keep the 40 gigabyte drive in this machine. And I was able to treat it like an 8 gigabyte drive instead of a 40 gig drive. Create a 2 gigabyte partition on it, copy all of the stuff off of this disk onto this disk, then plug that disk into the handy dandy contraption, and it was recognized on the Linux box downstairs then, and I copied all of the stuff off of it and backed it up. Finally. Now, this being said, I decided, well, we'll just hook this thing to the internal IDE interface. Maybe this thing's new enough that it supports LBA disk drive. No such luck. The built-in BIOS in this thing has a cylinder limit of 1024. It only works in CHS mode. It doesn't work in LBA mode, so I can't get more than like a little under 7 gigs worth of this disk working in this machine. The solution to this is to permanently install an XT IDE BIOS in the machine. We don't want it to be on an actual XT IDE card though. We just want the option ROM, the XT IDE option ROM in the machine, so that it boots that instead of the built-in IDE BIOS, and then it can access these drives. The Western Digital did make a what did they call it, Easy Drive or something like that, that's supposed to allow large devices to work on older BIOSes like this, but it's not good. I mean, I guess it works, but if you try to pull after you've got that, it installs itself in the boot sector, I think, first of all, which means that if you try to install grub, it overwrites it, and then you can't access your DOS partition. Also, I think if you pull the disk out and attach it to a different machine, that you can't read it. It fucks things up somehow. So the proper solution is to get a BIOS that can deal with LBA drives, and the XT IDE BIOS is the easiest one to do that with. Now, we don't need another IDE card in this thing because we've already got an IDE interface in this thing, but I do have this NE2000 network card that I plan on installing in this machine, and it does have a boot ROM socket. You don't have to put a PXE boot ROM in these. You can put any old option ROM you want in these ROM sockets in these network cards, and it'll boot it, including an XT IDE option ROM. So, as you can see, this card requires a 2764 ROM, which is, I think, an 8K UV-erasable PROM. Of course, when I was first trying this, I was too dumb to read the number underneath of the socket because, you know, that's how I am. So I tried the ROM off of this thing. This is a 256 ROM. That's a 32K electrically erasable PROM. And I also tried the ROM off of the XTCF card, which is a 28C64 electrically erasable PROM. This card requires a 2764 UV erasable PROM. So obviously these ROMs did not work in this card, which I should have known, but I tried it anyway, and it's fortunate that I didn't fuck anything up trying that. Because let's see. All right, so I don't have any 2764 ROMs. I think I can. I do have several 28C256 ROMs. I think that the 28. I think that a 256 ROM would work in this socket if you made 4 different copies of an 8K boot ROM and put them on the ROM. You know what I'm saying? So it would act like an 8K ROM in that case. The sockets are the same size. It's just that a couple of address lines aren't used on the 8K ROM. So you have to make 4 copies of it to make the card think it's an 8K ROM, even though you're using a 64K ROM. Or 32K ROM. Sorry, I'm dumb. I don't have any 256 ROMs either, and these are UV erasable ROMs, and you have to have like a tank with a UV light in it. You put the ROM in it and it sits in there for hours and like erases itself that way, and that is a pain in the ass. Who in current year wants to deal with that? So I would rather be able to use a 28 series electrically erasable PROM in this card, even if I can't program it in system. And if we look at the pinouts for the 2 chips, let me get my patented pointy thing here. We can see that the pinouts are very, very similar between the 2 chips. This is the old style UV erasable PROM. This is the electrically erasable PROM that everybody uses now in the XT IDE cards. This VPP pin on the old UV erasable PROM, I think that it is only used during programming for like a higher programming voltage or something. I'm too lazy to read the data sheet because I'm a piece of crap, so that may not be true. But if that is the case, then the VPP pin on the network card, it probably isn't even connected to anything because you program the things in a programmer, not in the card. The other difference is, see, A14 here on the 28 series has been moved up here to where pin 1 used to be that VPP. Alright, so there's our A14, and the original function of pin 27 has been replaced with this write enable line. That's an active low signal that allows you to write to the ROM in system. So these 2 pins, number 1 and number 27, are the only ones that have been changed between these 2 ROMs. Okay, so moving A14 up to pin 1 is an easy matter of cutting a trace and running a bodge wire on the back of the card up to pin 1. So that shouldn't be any big deal. And I don't think that'll be any problem to do. However, it would be really nice if we could jigger things so that we could program this ROM in system. And we wouldn't have to pull it out and put it in a programmer or a card that is actually designed for an EEPROM in order to program it. So I think that the ability to be able to do that on this network card depends on a couple of things. firstly, we have to assume that when the mem-write line on the ISA address bus is asserted, it'll still, the address decoding logic on the card will still assert the chip enable on the ROM. I can't imagine that it wouldn't, because that would be the simplest way to design the address decoding logic, and why would you make it more complicated than you had to, especially on these cheap NE2000 cards. The other thing is, there may not be the mem-write line on the ISA bus may not even be connected to anything on the card, because I mean, maybe all of the network functionality is accessed through I/O ports, and you know, obviously they weren't intending for people to write to ROMs in this card when the card was built. But I think these are two RAM chips up here, so maybe part of this card is memory mapped. I don't know. It's a little funny, and I don't remember off the top of my head what pin mem-write is on the ISA bus. I'm going to have to stop the camera and look that up. But if mem-write actually goes somewhere, and you know, looking at all of the edge connectors here, well, no, there are a bunch of missing ones on this side. If we've got a mem-write line somewhere, well, it'll be on the 8-bit section of the card. So if we've got a mem-write section, or a mem-write pin, that actually goes somewhere, it's not just a trace that goes nowhere, or a missing trace like you can see here, then we should be able to run a bodge wire from whichever pin that is to the cut trace, the other side of the cut trace for pin 27 here. And then, as long as we can figure out what the base address that this card is putting this ROM at is, we should be able to program it in system then. Let me see here. Here's the schematic of the ROM section of the XT IDE card, and I'm zoomed in too far there. All of this stuff here is just the address decoding circuitry, which the network card is already going to have on it, so we don't really need to worry about that. The part that's interesting is this is the 28256 ROM chip here, and we can look at the write enable pin on the ROM, and it goes to this ROM_WE signal, which is here in the address decoding circuitry. And if we look at this, all that this is in the XT IDE ROM implementation is this line comes from mem-write on the ISA bus and goes through this switch that allows you to connect or disconnect mem-write to the write enable pin of the ROM, and then it's got a 10K pull-up on it here, so that when you have the switch off, ROM write enable is always pulled high instead of floating. So the purpose of this is so that you can flip this switch to disable the writing of the ROM in system, like if you don't want to accidentally reflash your ROM or something, running the wrong software. However, that being said, if this switch wasn't here, if the mem-write line of the ISA bus were just permanently connected to write enable, that should be hash write enable. They labeled it wrong on this diagram. But yeah, if the mem-write line of the ISA bus were permanently connected to write enable on the chip, we shouldn't need these pull-ups. So as long as we just run a jumper from the edge connector, wherever the nearest VA is to the pin on the edge connector, up to the appropriate pin on the CPU socket, I think it ought to work. I don't see why it wouldn't. But then again, you know, I don't really know what I'm doing. I'm just an amateur. So we may destroy the network card. Who knows? Exciting. Let's try it and see what happens. So, apparently I'm full of poop. I thought I had like 3 or 4 28 256s, but I guess I don't. Maybe they're still downstairs and I haven't gathered them up yet, but that would mean they went in the wrong drawer somewhere, so I may never find them. But I do have one extra 2864, so even better, we won't have to make 4 different copies of the XT-IDE BIOS on a 32K chip. I mean, not difficult anyway, just have to cat them all together and then write the image, but you know, whatever. So yeah, I do have 2864 though, so I guess we'll use that. So that's what the card's designed for anyhow, or the 2764, so all the better, yes. Alright, so solder side pin number 11 is the memory write signal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There is a trace for it. Excellent. And there's a via that goes right through the board to this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to right here. So hopefully if we suck the solder out of that via, there will be enough space to insert a wire wrap wire. Where is my wire wrap wire? Alright, well, apparently I forgot to press the record button when I started this. I'm sorry. Dumber in hell. Alright, so there is pin 13 on the B side, that's memwrite. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, wait a second. Did I screw up? Where's my schematic? Memwrite. B side. Pin 11, okay. Oh, scared me for a second there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, very good. And it goes up here to pin 27 of the IC socket. That'll be right enable. Okay. And there's a trace that comes from that pin down here to this via. The trace is cut right here where you can see that little scratch, and there's a jumper soldered from that via up to pin number 1, which is not attached to anything. Not attached to any traces on the board, I mean, because that's the programming voltage. So I think that'll be good. It looks like I need to clean up my solder here a little bit. I've got a gloop there that I missed, and then I stuck the jumpers down with a couple of dots of super glue there, just to make sure that they don't come loose at a bad moment. And once that dries, I will clean my flux residue off of there. What I'm going to do, I think, is my my other ROM doesn't have anything on it. It's brand new, but I've got a 28C64 right here in this XTCF card. So it doesn't have the I/O ports set right, so this won't actually like cause the machine to boot if I put this ROM in here, but I'm going to put this one in here because I know it's got something on it that the machine should be able to execute. And then we'll be able to tell whether this modification actually worked or not. If it didn't work, I guess I'll just solder through that trace that I cut and take my jumpers off and put it back the way it was. But it ought to work. What are the chances it won't? Yes. So here I go without a proper ROM puller. You guys can cuss me if you'd like to. Go ahead, leave it in the comments. What are you doing, Lee? I'll tell you what I'm doing. Getting her done. Yeah, see? Yeah. All right. Things lined up right. Get super glue on my fingers here. Yeah. All right. Well, hopefully this won't let the magic smoke out. Let me clean up here a little bit and get the machine back over here and we'll see what happens. Up there. So the network card's in the machine. About ready to do a smoke test. You think something's gonna blow up? I don't know. Here, I'll give you a close-up on the magic smoke here. Well, I didn't see any poof. That's a little disappointing. Let's see if I can get you on the screen here. Ah, point, you dirty rascal. Well, it didn't try to boot the ROM. Alright, I did a little bit of reading, and apparently this is a non-ISA-PNP jumperless board, and I will have to obtain the configuration software in order to enable the boot ROM. Okay, it's the next day, the next afternoon I should say. Saturday afternoon. I have to once again apologize. I was helping a buddy of mine do some high voltage electrical wiring and we drank way too much while we were doing it, so I apologize if I sound a little too much like Tom Waits for the rest of this video, but we shall push through our miserableness and continue. Here's the chipset on the card. Apparently this National Semiconductor Atlantic chipset can emulate either an NE2000 or some sort of Western Digital chip. Apparently most of the NE2000 cards had a different chip on them, so hopefully this will work. It may not, I don't know, but this is, according to the silk screen on the board, this is a Novell card. I assume it's actually a Novell Eagle card, manufactured by Eagle for Novell. Considering that I think it's one of the plus versions of the card, since it is indeed jumperless. I think all of the original NE2000 cards were jumpered. So here on Mr. Monitor is the software. So it appears to recognize that we have a card here, and we can change the settings here. I'm going to write these down because I'll probably need to know them when we try to load the packet driver, so give me a moment here. Okay, I think this is another thing about that Atlantic chipset. It's something it has over the original NE2000 chipset. It can be run in a PIO mode or a shared memory mode, and apparently the shared memory mode is much faster. But it was in PIO mode apparently, and I'm going to leave it in PIO mode just until we get things working, because I don't want to deviate from the norm. It might just cause more problems, and that'll just be more to track down. So yeah. And here is what we have to do to get the option ROM enabled. Now I want this to exist at the same location as my XTCF card because I know it works, and it defaults to D000. So we will set. And why does it say it's going to change the IRQ to 4? I don't know. I'm going to set that to D000. Hopefully that'll make the option ROM work. Maybe it'll let us change the IRQ back to 12. Yeah, okay. Alright. I have no idea what this is, so I'll leave it at the default. Okay, whatever. So it changed the interrupt to IRQ4. I'll change that back to IRQ12. And hopefully that has the card set up. I guess you think we should go ahead and run diagnostics. I've never run this program before, so let's see what happens. Shared memory test failed. That may be because we don't have it enabled. I probably have to have a loopback cable in for that. Okay. No, we don't want to do that. Okay, yeah, so let's reboot the machine and see if the option ROM runs. We have no XT IDE card plugged into the machine right now, and the ROM that's in here doesn't have the right I/O port configured for the onboard IDE interface, so it's not going to boot. But if it at least loads the option ROM, then we'll know we're on the right track, and I can put that ROM back in my XTCF card, put the blank ROM in there, and we can configure the proper ROM to write to the card and see if our in-system writing mod also worked. So problems may occur. Okay, we've got a boot ROM installed in the card. Okay, fine. Alright, so here goes nothing. We have to power cycle apparently instead of just do a warm reset. So wait for the hard drive to spin down. Alright, here goes nothing, boys. Let's see what happens. I need to get some more RAM for this thing too if we're going to run Linux on it. I think I'll put Slackware on it. Slackware is actually still maintained, believe it or not. Fascinating. It should run very well on 486. It's one of the few distributions that still compiles kernels that will run on a 486. I don't think it will run on a 386. Oh, look at that! It loaded the XTE BIOS off of the Ethernet card. It loaded the EEPROM BIOS. Our mod is working. And, well, that's interesting. So after that BIOS failed to boot, it went on to the built-in BIOS thing. But this is good. Our mod worked. I'm actually rather surprised. Okay, let me install the blank ROM and do a little research on what ROM image we need, and I will be back with you in a moment. Okay, so I did a little bit more fiddling here as I was copying my XTIDE BIOS files and stuff onto the disk drive, and it looks to me like, remember that little 2 megabyte partition, that 2 megabyte non-DOS partition that was on the front of this disk? Well, apparently that's the BIOS setup utility, because when I unplug the disk drive I can't get into BIOS setup at all. So that's not cool. I can't get this disk backed up at a low level, so there's no way for me to preserve that partition. I think the only way that I'm going to be able to make that happen is to image the drive on this computer some way. I'll have to find a utility to do that in DOS, I guess. What a pain. But before I do that, let's get NFS working, and then I can just save the image over the network and everything will be, you know, happy and stuff. So anyway, but before we do any of that, let's get this XTIDE BIOS written. So let me mute the screen here. Alright, that'll have to be good enough. Now, I've never done this before, so I may screw up. Bear with me. Let's see what happens here. Alright, so we want to load a BIOS from a file, and we want to use this 386 BIOS, I think. Okay. So let's configure it. Our primary IDE controller should be, yeah, that's correct. Okay. We'll just leave that at 370. If it's got a multi-IO chip on the motherboard, that's probably what that VLSI chip is. It probably has a secondary IDE interface on it, but it's not hooked to anything on the board, so okay. I don't know what that does. Okay, so we don't want that. Oh yeah, okay. We can change the boot drive in this BIOS so you can boot off of something other than the first disk. I don't think we need to do that. Let's see, we already did that. Well, we've really only got one IDE controller in this thing, so yeah, that should be at 1F0. Okay. No, let's leave that off. Okay. Well, now we'll find out if we can flash the EEPROM after our budge wires. What do you think's going to happen? You think the magic smoke's going to come out? I don't think it will, so I won't point you back at the computer. It'll be more interesting to watch it here. Yeah, we got a 2864 in there, and it's a D0. Yeah, okay, let's go. It appears to be working. No smoke's coming out yet. Nothing's exploded. There's still oxygen in the room. Will it work? Will it work? I have to say, this is much handier than fucking around with a USB programmer. I may do this to all network cards from now on. Yeah. Written successfully, it says. I guess we'll see what happens. It's rebooting. Hey, there we go. There's our XT-IDE BIOS running off of the network card on a 28 series EEPROM rather than a 27 series UV-PROM. Excellent. But it hasn't booted yet, has it?